A developer recently gave a new AI model a coding task. And instead of instantly spitting out a wall of text, the model did something eerie.
Yeah?
It paused, it mapped out the architecture deeply, it actually asked a few clarifying questions first.
Right, which is wild.
And it built a clear plan of attack.
Right.
It behaved exactly like a senior software engineer.
It really is a fundamental shift in machine behavior. You were watching basic pattern matching evolve into true reasoning.
Welcome to the deep dive. We are exploring something truly fascinating today.
Absolutely.
So, Anthropic recently pulled Claude Fable 5 from public access. And this was due to a new export control order.
Yeah, things are getting highly restricted out there.
Right. But ZAI did the exact opposite. They just released their new model, GLM-5.2.
Completely out of left field, too.
And it is completely open. It is remarkably cheap, and it is entirely free to try right now.
It really is a profound contrast in industry direction. One massive door closes tightly and another door kicks wide open.
Today, we will unpack this new frontier model. We are going to explore its shocking benchmark wins. We will break down its highly disruptive pricing, and we will explain exactly how you can use it today.
It's a critical moment for open weight models. You really need to understand what is happening here.
Okay, so let us start with the underlying machinery. What makes this senior engineer behavior actually possible?
Right.
ZAI built GLM 5.2 as their absolute flagship model. It focuses heavily on three main areas.
Yeah, advanced coding, complex agent tasks, and long horizon work.
That last point is incredibly important right now.
Oh, it's everything. I mean, many models excel at giving quick, short answers, trivia or whatever.
Right.
But they completely fail during a long, complex workflow. GLM 5.2 is designed to maintain strict reliability.
It stays focused through days of sequential, complex steps.
Exactly. It doesn't get lost in the weeds.
So it relies on three core pillars of architecture. The first is a 1 million token context window.
Which is huge.
That is an enormous amount of raw information.
It really is.
Yeah.
I mean, you can load a massive code base inside it. You process the entire project in one single pass.
Wow.
Yeah, you do not have to chop files up anymore. It just reads the whole thing.
The second pillar is an open MIT license.
Super permissive.
Right. And the third pillar involves its two distinct reasoning modes. They are called high and max.
We will definitely explore those specific modes later on.
But first, let us look at its actual size. It features 753 billion total parameters.
Massive.
But, and this is the interesting part, it uses a mixture of experts setup.
Right, the MoE architecture.
Yeah, so it only activates 40 billion parameters per token.
Beat. Can you explain what a mixture of expert setup actually is?
Yeah, simply put, it only activates the parts of its brain needed for the task.
Okay, so it operates kind of like a massive university campus.
I love that analogy. Yeah. You do not consult the entire school for one single problem. You just walk into the specific department you need.
Exactly.
You visit the physics lab for a gravity problem.
Right.
You ignore the English department entirely.
You don't need them for that, so you save the energy.
But wait, I have to push back on this a little bit.
Sure.
If it is a 753 billion parameter model, but only using 40 billion at a time, aren't you losing the deep intelligence of the other 700 billion? Like, how does it actually know it is picking the right experts?
Well, that is the genius of the internal routing network.
Okay.
The model has this specialized gateway layer. It analyzes your prompt instantly, before processing the actual answer. It mathematically calculates which specific expert clusters hold the relevant knowledge.
Oh, wow.
So you are not losing the intelligence at all. You are just filtering out the noise.
You keep the raw strength of a massive system, but you run it much faster overall.
Exactly.
Yeah.
And you use significantly fewer computational resources doing it.
It is highly efficient.
Highly, yeah.
This leads me to a really critical question.
Okay.
Why does an open MIT license matter so much right now? I mean, API access is incredibly ubiquitous across the tech industry. You can just rent access anywhere.
Well, because you are completely independent from centralized corporate gatekeepers.
Right.
An MIT license offers a very permissive legal framework. You get the absolute freedom to host the model yourself.
You can edit the underlying weights directly.
Exactly.
Yeah.
You never have to worry about a company pulling access overnight, like we just saw with Anthropic.
So you own the engine entirely instead of just renting the steering wheel.
That's a perfect way to put it.
Yeah.
Right, and it guarantees your long-term stability. You can actually build a business on it safely.
The theory makes perfect sense.
Yeah.
But a massive architecture is only useful if it actually delivers results.
True.
We need to see how this lightweight expert performs. Let us compare it against the major industry giants.
Let's do it. So the baseline comparison is its own predecessor, GLM-5.1.
Right.
The new benchmarks show a massive jump forward. It is not just a minor incremental update here. It is a paradigm shift.
It shows clear gains in 3 distinct areas.
Coding, advanced tool use, and deep reasoning.
Yeah. So on Terminal Bench 2.1, the old model scored 62.0. The new GLM-5.2 scores a solid 81.0 points.
That is a very respectable leap in performance.
It is. But the deep SWE score is truly shocking to me.
Oh, yeah. That one is wild.
GLM 5.1 only hit 18.0 on this benchmark.
Which was, fine at the time.
Right. But GLM 5.2 jumps all the way to 46.2.
It more than doubled its previous capability score.
That is incredible.
It is. And keep in mind, deep SWE measures how a model handles much harder tasks. It is not just writing simple Python scripts from scratch. It is fixing deep, complex architectural bugs within existing repositories.
Real-world engineering.
Exactly.
Now let us compare it to the closed models.
Okay.
On the Long Horizon Frontier SWE benchmark, GLM 5.2 hit 74.4%.
Which is deeply impressive for an open model.
It actually passes GPT 5.5, which sits at 72.6%.
Yeah.
And it trails Claude Opus 4.8 by less than a single point.
Right. Opus is currently at 75.1%.
It is a highly nuanced picture, though.
Oh, for sure.
It does not win every single category across the board.
No, it doesn't.
Like on post-train bench, GLM 5.2 scores 34.3%.
Right.
This is lower than Opus 4.8 at 37.2%.
But it remains higher than Opus 4.7.
True.
It also beats GPT 5.5 and Gemini 3.1 Pro there.
And on SW Marathon, GLM 5.2 holds second place overall. It scored 13.0% on that specific evaluation.
Yeah, it sits slightly behind Opus 4.8 and Opus 4.7.
But it stays ahead of GPT 5.5 and Gemini 3.1 Pro.
This proves it is a true frontier-level competitor. It trades blows with the absolute best models available anywhere.
It does. Then we arrive at the biggest surprise of all.
Oh, man, the design test.
Yeah. The model was tested on Design Arena.
Right.
This is a community-voted benchmark for web design. It focuses heavily on front-end generation and visual aesthetics.
Which is usually a weak point.
Yeah.
But GLM 5.2 achieved first place on this entire leaderboard.
First place.
Yeah, it earned a highly respected 1360 ELO score.
Wow.
It actually moved ahead of Claude Fable 5.
Whoa. Imagine an open-weight model not just writing back-end code, but generating interfaces with actual visual appeal.
It's crazy.
It is usually all logic and absolutely no style.
Yeah, it is a massive breakthrough for open source AI. Open models usually struggle deeply with visual aesthetics.
Why is that?
Well, there is a clear reason for that. They are trained heavily on scraping raw code repositories like GitHub.
Right.
So they learn pure functionality. But they do not learn human-tested visual layouts. They can write the underlying functional logic perfectly.
But the buttons and layouts usually look terrible.
Exactly, just totally unstyled blocks.
So how does an AI model actually get graded on something as subjective as visual appeal?
So the ELO system relies entirely on crowdsourced human voting.
Really?
Yeah. Real developers look at 2 different front-end designs blindly.
Okay.
They vote on which interface actually looks better visually. It bypasses automated rigid grading completely.
So humans blindly vote on layouts, teaching the model actual subjective aesthetic taste.
Right. It relies on genuine human preference.
That is fascinating.
Yeah.
Beating top models in benchmarks is one thing entirely. Doing it without raising prices is something else completely.
That is where the industry really feels the economic impact.
It goes against the current market trend completely, doesn't it?
100%. Most AI companies raise prices with every new capability.
But GLM 5.2 kept the exact same API pricing.
It's wild.
It costs the same as the older GLM 5.1. Let us break down the exact economic numbers here.
Okay, so input tokens cost $1.40 for every 1 million. Output tokens cost $4.40 for every 1 million.
And cached input is exceptionally cheap to use. It costs just $0.26 for every 1 million tokens.
Right. They also have a limited time free offer on cache storage.
Let us compare this directly to the competition.
Sure. Claude Opus 4.8 charges $5 for input tokens.
Okay.
And it charges a massive $25 for output tokens.
Wow. GPT 5.5 also charges $5 for input tokens.
Yeah.
But it charges $30 for output tokens.
That is a huge jump. And Claude Fable 5 used to charge even more. It was $10 for input and $50 for output.
That was before it was pulled from public access. The price gap here is absolutely staggering to see.
It really is. I mean, think about it. If you are a startup building an AI agent, making thousands of calls,
Yeah.
a $30 output versus a $4 output completely changes your business model.
It is the difference between a viable product and bankruptcy.
Exactly. It places GLM-5.2 safely in the mid-range tier economically.
But it delivers top-tier, frontier-level reasoning capabilities.
Z.AI is clearly prioritizing long-term market adoption here. They want developers embedding this deeply into new products.
They also launched a specific GLM coding plan.
Right, the subscription.
Yeah, it is a separate subscription built specifically for software development. It starts at $18 a month for the light tier.
And they have Pro and Max tiers for heavier workloads.
It is tailored for high-frequency, complex coding tasks.
Exactly.
But with prices this low, is the API meant for enterprise scaling or just personal testing?
The API is explicitly built for heavy product integration.
Oh, really?
Yeah, it allows developers to scale massive automation workflows rapidly. You get frontier performance without destroying your monthly operational budget.
Got it. The chat is a playground, but the API drives scalable business engines.
Exactly. It changes the fundamental math for startups. 2-sec silence. Sponsored.
Now that we understand the raw power and price, let us talk about how you can actually use it.
Because you can get your hands on it today, easily.
You have a few different access options available, but first let us detail those two reasoning modes.
Right.
You mentioned high and max earlier in the show.
Yeah, so GLM 5.2 lets you pick how deep it actually thinks.
Okay.
You control the speed, cost, and quality all at once. The high mode is fast and perfectly balanced.
You turn this on through the thinking parameter settings.
Exactly. It answers much faster while maintaining very good quality. It is perfect for everyday tasks like writing emails or, generating simple, straightforward code snippets quickly.
Then you have the max reasoning mode available.
Yeah, the heavy lifter.
Max pushes the model to think much, much deeper. It pushes the extreme limits of logical problem solving.
You use this for complex, multi-file code refactors.
Right.
Or incredibly hard debugging sessions inside messy legacy code bases.
So you trade some speed for noticeably sharper, accurate answers.
Right. You turn it on using the reasoning effort parameter.
And you can also add web search to these requests.
Yes, which is huge.
It costs just 1 single penny per search call.
Pairing web search with max mode is incredibly powerful. You get deep thinking combined with fresh, current information.
There are 3 main ways to access this model.
Let's rank through them.
Option 1 is the official Z.AI chat interface.
Right.
It is completely free to use right now. You do not even need an API key.
And it works seamlessly right inside your web browser. You just pick GLM 5.2 from the drop-down model list.
It even supports large file uploads up to 10 megabytes.
Which is great for documents or small code bases.
This is best for someone testing the waters first.
Definitely.
Option 2 is utilizing the Llama Cloud platform.
Yeah, this specific route does require a paid monthly subscription.
But it runs the model on US-hosted GPU infrastructure.
Right. And it is highly focused on strict data privacy protocols. Your prompts and responses do not get logged anywhere.
That's vital for a lot of companies.
Yeah, they are never used to train the model again.
One important note about this specific Llama option,
Okay.
the model only runs through their cloud infrastructure servers. You cannot self-host it on your own normal hardware.
Right. The model size goes well beyond what normal computers handle.
Then option 3 is using the Open Router platform ecosystem.
This is where you create your own API key.
You call GLM 5.2 through a standard access endpoint. The system routes your request to the best server. It optimizes automatically based on speed or current price.
It works perfectly if you use several different models. You manage all of them through one single access point.
So real-world application demos are where things get really exciting.
Oh, absolutely.
Benchmark numbers only tell you part of the true story. We need to see what happens in actual practice.
And the community has been testing it hard. Demo 1 was a side-by-side test on X.
Right. They used the exact same prompt and reference image. They asked GLM 5.2 and Claude Opus 4.8 to compete.
And the task was building a 3D logistics dashboard interface.
Both models successfully produced a working 3D interactive globe.
Which is hard enough.
Right. They used the Three.js library to build the complex visualization.
Yeah, and it featured complex route arcs and transparent glass panels.
It looked incredible. The final layout was highly polished and professional looking.
GLM 5.2 held its own completely against Opus 4.8.
Which is crazy because complex 3D interface work is usually dominated by closed models.
Exactly. But Demo 2 is even more fascinating to look at.
Okay, tell me about that one.
Someone ran the model fully local on a Mac Studio.
Fully local.
Yeah, they used a heavily compressed 2-bit quantized version.
Let us pause here for a second. How exactly does quantization shrink a massive model down?
Think of it like compressing a high-resolution RAW photograph.
Okay.
You shrink it down into a smaller JPEG file. Quantization strips out the extreme decimal precision of the model's weights. You lose a tiny fraction of nuance, but it reduces the memory footprint drastically.
Oh, I see. This allowed it to fit on personal consumer hardware.
Right. And the real-world results actually came out better than Opus 4.8.
Wow.
It now powers a Hermes agent and codec setup locally. It is completely free and totally private on that machine.
I still wrestle with setting up local quantized models on my own machine.
Oh, absolutely. I mean, the dependency errors alone will drive you crazy sometimes.
Yeah.
It is definitely a highly technical, frustrating process, but the ultimate payoff is having complete, uncompromised privacy.
Right. But if the free chat does so much,
Yeah.
when does a user actually hit the wall and need the Llama Cloud or OpenRouter options?
You hit that wall when you need deep automation. You need APIs to integrate the model into custom software. Or, when your personal hardware simply cannot run quantized versions.
You upgrade when you need automated workflows or your laptop just can't handle it.
Exactly. The chat is great, but APIs build actual products.
Let us zoom out and recap the big ideas here.
Sound good.
What is the core narrative of this entire deep dive?
GLM 5.2 is much more than an open source alternative.
Right.
It is a massive 753 billion parameter mixture of experts frontier model.
It achieves top-tier reasoning capabilities across the board. It designs beautiful UI prototypes that look truly finished. And it does this at a fraction of the cost.
It keeps the entire AI ecosystem highly accessible today.
Especially while gatekeepers are actively tightening their grips on advanced models.
Right. ZAI is providing a powerful, stable, open alternative right now.
It does not fully replace closed models in every single scenario.
No, not every single one.
But with its price and openness, it earns a spot. It belongs in every serious developer's modern toolkit today.
It is a fascinating evolution of the open source landscape.
It really is, and it leaves you with a very profound final thought.
Okay.
A free, open-weight model can now pause and reflect.
Yeah.
It can ask deeply clarifying questions about a prompt. It can map out a complex software architecture project. It does all this before writing a single line of code.
It's unbelievable.
Essentially, it is flawlessly mimicking a senior human engineer. So, what exactly does the role of a junior human developer look like 5 years from now?
Man, that is the defining technical question of our generation.
Thank you for joining us on this deep dive. Keep questioning the tools. Keep exploring the frontier. Out to row music.